Hello and welcome to this video. Today I am going to be going over an exam question from a biology paper. The main focus for today is to really know and really grasp how to answer a graph question, how to plot a graph. So we finished answering this, right? And now we are told in 2.6 to complete figure 3. So figure 3, okay, it's already got a title here and you've got a graph here. Let me just rub this out. I don't know what this is. So you should use a suitable scale for the y-axis, plot the data from table 2, and draw a line of best fit. And this is 4 marks. Right, so you can see here, if you have a look, okay, your graph already has the axes that are labeled. If they are not labeled, you do need to label it yourself. Right? And what is even more useful is that they've done these scales for the percentage of coronary artery that is blocked. But you have to pay special careful attention to this bit, which I will talk about soon as to how you're plotting it. Because look at this value here. You've got 50 here and you've got 40 and 60 here. So you've got to be careful about that. So the way that I would approach this is just keep it simple. Go step by step with everything that you know about how to plot a graph. So, and here you've got a guide on what exactly you should do. Okay, so you should use a suitable scale for the y-axis. Let's try that. Okay, they've given you everything step by step. Use it. So, you've been given, let's see how many squares we are given. We're given a lot more squares for the y-axis. Okay, by the way, this is the y-axis. I'll just label it just in case, just to make everything clear. Right, so the y-axis is the blood flow in centimeters cubed per minute. Let's have a look. So we look at our data set. Okay, you don't have to look at the left side just yet. You're looking simply at this, and we look at the values that we have here. So we've got 2, we've got 8, 42, 60, and 100. So now you've got to think, do I want to go up in tens? So 10, and then it'll go up to 20, it'll go up to 30, 40. Do we have enough space for that? Do we have enough squares for that? Or do I want to go up in, would it be wise for me to go up in twos? So 2, 4, 6, 8, 10. Have a think about this. Would I ever reach, I would need loads of graph paper to go up all the way to 100, which is our highest value here. You don't want to do that. You want to have an appropriate scale. Okay, so for example, it wouldn't be wise to go up in ones even, which is even worse. Okay, so you'd have to go up in some sort of value, like up in 20s, up in 10s. Let's see if the 10s works out. So if we go up in 10s, do we have 10 squares here? So we've got big squares and we've got small squares. So we could try these type of squares here and see if we can go up in 10. So you can see the outlines here of these squares here. So this is one big square, and that is what you use as your guideline. That is what I'm using here. And the small squares you can see here are 5. So these are 5 squares here. Right? So make sure that you draw small dashes. And if you look on your x-axis, they have done that for you. They have done that for you. Look, so they've done the dashes for you. That is another clue that you should take if you ever forget. Right? So the squares, the bits of the table of the graph that they've labeled for you have these little dashes. So you should add these dashes here. By the way, you should be a lot more neater than I am. And always use pencil, because that is your actual exam. You don't want to risk it and then have not have another copy for you to work on. You want to be able to do your graph appropriately, and also if anything goes wrong, you can you can erase it and then try again. Right? So that is what you want to do. I'm just going to make this a bit longer. And there you go, you've got a dash here. Now let's see if we can go up in 10. So we start from 0. The scale's already starting from 0. You can also write 0 here. 10, let's write 20, 30, 40, 50, 60, 70, 80, 90, and 100. Oh wow, so we've got more than enough space here, more than enough space, and we've got an appropriate axis. I will be able to clearly show each of my points, right? And then the thing that we have to do is go ahead and plot these. So go up to your data set. Let's have it. So the way that I would suggest you do this, again, keep it simple, straightforward. Once you do the first set, you could even annotate your question. So you could make just a little tick, just to make sure that you've done it. Okay, you've done these coordinates. Any way that you find suitable, keep it simple and keep it straightforward. So 0 and 100 will be the first one. Okay, this is the reason why I say to do these things, that even the ticking is just to make everything clear for you and to avoid any silly mistakes or any small little mistakes in your paper. So let's do these 0 and 100. Very straightforward. You go down to 0 for the percentage of coronary artery that is blocked. Let's go up to 100 for our y coordinate, which is blood flow. And then all you do is make an X there. Very clear X, okay? Right, so let's go up to the next one. 10 and 64. So I would not go up to this one. I would not count up 10 squares and go up to this one. That is 20, right? So between this line here, let's have a look. So between this line here, that's 20. So I know that halfway, which is 5 squares and then 5 squares and then 5 squares, that is 10. Right, so let me write that a bit more clearly. Okay, so you can annotate it, that's fine, just to help you, right? But just to make it neater, I'll take it away. So go up to 10, and what was the other one? 10 and 64. So we are at 10, and we need to go up to 64. Now this is going up in twos if you have a look at it. So this is the value between this is 10, but you've got 5 squares. So if you count it, you're actually going up by 2 squares every time. So this would be 62, 64, 66, 68, and 70. You can always check this and see that you're right or not, okay? So go up to 10, and then that is 62, and that is 64. So be very accurate. Okay, make an X there. Right, so next one. 20 and 42. 20 and 42. So now we can go up to 20 and then move up to 40, 42. Right? And then we go up to 50 and 8. So 50 and 8. Go up to 50 here. Would be here. And then 8 would be plotted here. And then you do 80 and 2. 80 and 2. Right? There you go. So that is our graph plotted there. Now, one thing that you have to notice about this is that does this seem to go in, is this a scatter graph? So what I mean is by scatter graph is that your points are scattered, literally. So for example, if this was a scatter graph that is, going down, that would be kind of like a scatter graph. But here you can see that you've got a clear points that link together in a sort of pattern, right? So for this one, it would not really be suitable for us to draw just a line of best fit like this, right? Because that is the third point on here. We have to draw a line of best fit, right? But for the scatter graph, yes, it would. It would be quite suitable. Not quite a straight line, but you get what I mean. You've got a straight line. You can have a straight line here just to show kind of how the data is going in terms of the pattern. And that is what line graphs can be used, lines of best fit can be used for, to display the overall pattern in the data. But for this one, you can see that the data curves, right? The data curves. So we would do something a bit more different. Let me try and rub this out. We would do something a bit more different, and instead we would draw a curve. So if you said draw a curve instead, you are correct, and you would draw a curve. Now, these are really ugly diagrams. Please do not do this. And also, the thing about drawing curves is that, don't really be afraid of getting it wrong. This is why you do it in pencil, so that you can trial and test it many, many times in case you do get it wrong. So, for example, if I end up doing this in the exam, and also do it in pencil, like I said, do it in pencil. I know I'm doing it in red just to show a different color, but do it always in pencil. And what students can tend to do is try to sketch it out, try to sketch it out like pencil. It can be quite tempting to do that, but please do not do that. Instead, do it all in one go. If I can do it. Or I'm just going to have to do it like this. But if you are in the exam, obviously, try to do it all in one go, one continuous line. But this will do for now. I think this will do for now. Let's see. Yeah, and that is your graph done with and then you can do the checklist at the end. Obviously, you have only 4 minutes, about 4 minutes to do this. But obviously, I'm just giving you a walkthrough step by step of what you have to do. So suitable scale, plot the data from table 2. We've done every point, so you get the mark if you plot every single point. I'm not sure how it is for this mark scheme. Let's have a look. But it has to be, it usually is every point if it is said like this. And then draw a line of best fit. That is the point there. So let's see how the marks are distributed for this. Have a scale on the axis. Like I said, all points need to be plotted. And then a correct curved line of best fit. So they tried to say line of best fit. Don't always think that it's a straight line. It will be curved. You just have to look at how the data works. It says ignore line joined point to point with straight lines. Now you have to be really careful with this. Why? Because you could have just done it like, for example, you could have just done it like this. So say it's going down, okay? You do not take a ruler and do this, okay? You do not do straight lines. That is not the curved line of best fit. That is just joining it from point to point. And same thing for the scatter graph. You do not join everything point to point. You do curved line or straight line of best fit with the ruler in one go. If you have to take multiple attempts, you do it, but you do not join you do not draw straight lines from point to point, right? Usually in science, it's best if you make the graph as big as you possibly can because it helps you display that data really clearly rather than having a really, really short y-axis with all the points squished in one place. That's not really showing you the data. So think like a scientist, think about how you can display your data in the best way possible.